Hi everyone and welcome to this my video on vector projections, part of the specialist maths course here in Australia, but vectors pretty much universal, so hopefully you'll find this video useful. My name's Darren from, yes I say it every single video, Maths Guru, my little corner of the interweb, where these lessons, downloadable lesson notes and summary books for general maths and others coming soon are all for you to find. Now, learning objectives, understand what a vector projection or vector resolute is, and understand the term rectangular components. Oof. Now, this is building on previous lessons, which again can be found on mathsguru.com, and is taking all of the vectors work and just making it a little bit more complicated each section we get to. And this one, vector projections, is actually pretty awesome. There's a lot of dots, a lot of multiplications, a lot of formulas. But if they're in the summary book or you just remember the key ones, you should be okay. I promise you, all right? But we've looked at the dot product or the scalar product as it's called. We're pretty much going to use that to help us find the shortest distance between two vectors. Now, hopefully you know that the shortest distance between any 2 points is a straight line perpendicularly between them. And this diagram pretty much says that here now. So if I've got this point here, all right, which is at the end of vector A, all right, and I've got this line here, which we will say is vector B, then if I wanted to find the shortest distance between the two of those, it would be a line at right angles to B. Oh, hold on a moment, right angles. We like the ideas of right angles. We've come to those a moment ago because we knew that A dot B is equal to 0. Oh, okay, so we're going to build on that from the previous lesson. So let's have an example here that we've got two vectors A and B joined at this point here with theta. Now again, really useful because we've looked at the idea that, well, if I'm trying to find this angle here, these two vectors have to be joined at that point and heading away from that point to be able to use that angle there through the dot product. Okay, so we've got A, we've got B. Okay, well, we know the shortest distance now between those 2 points is that line there. So let's call that W. All right, well, we can do that. So we now know that A is equal to vector U plus vector W. Now, I should really do these squiggles underneath. Okay, but we also know that W dotted with B, all right, and again, W dotted with B would give me 0. So W dotted with B, no, don't put it there because that's the times. W dotted with B would have to be equal to 0. But what is U? Well, U is some fraction of that vector B. All right, okay, so then what we'll say is, we'll say let U equals KB. I'm not going to put the times sign in. Okay, so U is equal to K times B. Well, what can I do with this? Oh, well, hold on a moment. We know from this one here that W can be expressed as A minus U. We know that W is therefore A minus some constant of B. So let's do my squiggly lines under here. And now because we got this W there, I'm going to substitute it and say, well, therefore, A minus some constant times B dotted with B must be equal to 0. Well, again, from the previous video, we know that there are certain relationships and certain things we can do to multiply this out. And we know, therefore, that becomes A dotted with B minus KB dotted with B is equal to 0. So rearranging that gives me KB dotted with B is equal to A dotted with B, or K is equal to A dotted with B divided by B dotted with B. He says deleting that by mistake. Aha! Well, how is that going to help me? Well, we now know that we can find this vector here, U, by basically substituting it back into here. We know that U, this vector here, all right, which is the length from this point here to that vector there, can be therefore found that U is equal to K, which we now know is A dot B over B dot B, all right? And that is times, so I'm going to put that in a set of brackets, B with my squiggles underneath. Now, all of those should have squiggles. But we now have a way of finding that.